Thank you. If you have the slide, please.
Yeah, thank you so much. All the elders here in the career, you are well acknowledged. I'm Ezekiel Oiganji from University of Jos, here to present smart irrigation technologies for sustainable water management, the innovative research and practices in Africa. The next slide, please. So globally, we know agriculture accounts for 70% of all fresh waters for food, feed, fiber, and biosphere. The water scarcity we know is aggravating as a result of accelerated urbanization, population growth, industrial and climate change, rainfall unpredictability, and agricultural development. So climate change has altered hydrological cycles, making water more unpredictable and increasing the frequency and intensity of floods, and also increasing desert encroachment. Next slide, please. So we have in Nigeria here, we practice on, and some of them we are yet to get to this level. We have a different type of irrigation method. The surface is there. We have flood irrigation, furrow, check, and the border. This is under surface irrigation. We know as a result of that method, we know it leads to conveyance losses, deep leaching, and what have you. Then we have sprinkler irrigation there. We have the solid set system, movable sprinkler system, center pivot, the ring gun system. Then we have the micro irrigation system, the drip system, the subsurface drip irrigation, micro spray tube, and bubbler irrigation. A lot is being practiced here, but a lot we are still yet to start practicing them. The next slide, please. Now, for some of these rural settings where water is so scarce, this is, they call it Ola irrigation, or the use of pitcher or clay pots, where they apply water here. It seeps through the pores of the pots just to get to the plant. The next slide, please. Now, in other climes too, you have the use of your swan or bottled water container connected to the infusion set, medical infusion set, is regulated there. They use this. The two other slides there, my student used that to grow onion as a research. The next slide, please. Now you have, for those who can't use the normal conventional drip system, they have something like this, the bucket there. They collect the drip lines, and you see where they cannot get metal stand for, they use wood there. Well, it's treated against termites, and you see the container there. The next slide, please. Now you have hydroponics, soilless agriculture. You see friendly is being practiced mostly in urban cities where they don't have land. Some of them even do it on their fences, on passage in their structures, and in other places where the soil is contaminated. This method is advisable. Then the next one, please. Aeroponics, where the practice of growing plants in air or mist. This one, the plant roots are suspended in the air and misted or rich air. That air is, the mist is rich in nutrient and is sprayed periodically with a nutrient solution to the root of the plant. Here, 90% is 90% more efficient than the conventional system. The next slide, please. Now, despite the level of abundant water resources we have and investment in irrigation, when you go to the northern part, go to somewhere like Kano and all of that, you see investment. But with all of that, we still fall short of meeting current food demand. And there's an urgent need to employ technical, agronomic, managerial, and institutional strategies-based technology for sustainable use of water. So there's crucial need for food and water security in Nigeria. The next slide, please. Next slide. Okay. Now, the systems we've shown so far, what are the challenges? The first one there's water waste. Now, mostly when you employ the flood, you either have over-irrigation or under-irrigation, and other places where it's over-irrigated, you have water logging, and which leads to salinity and also soil degradation. The other one is inefficient scheduling, where even in our the data we have, some of them some of the met stations, they are not even consistent. People who are supposed to be getting data, it's not there. So when they need to irrigate, is pre-scheduled irrigation. Most of the time it's inefficient. Then you have groundwater depletion, then soil salinity and nutrient loss. Then you have high labor and energy costs. The next, please. No, the next, please. Next slide, please. Now look at the trends in irrigation. Look at these other climes. 1970, they were already doing automatic control system. Then we have 1985, there is emergence of internet for public use. Then about year 2000, they are talking about cloud computing and storage technology. Then 2010, they are talking about Internet of Things. But if you look at this, if you want to compare our times and theirs, you will see that we are far beyond or 1970. This where the automatic control system was done 1970, but we are yet to get to that level. The next slide, please. Now, the need for smart irrigation. What is up to 60% of water is wasted due to inefficiencies, and we have 2.3 billion people face water shortages. Okay, smart irrigation. Go to the next one, please. Smart is a technology-driven approach that applies precise water amounts based on real-time environmental conditions. Now, for other ones we've seen, most of the times you don't get the real-time condition of the soil. So, more or less, you either apply over-irrigate or under-irrigate. Then this one allows farmers to apply more water efficiently. Then it integrates Internet of Things, sensor, artificial intelligence, automation, and weather data analytics to determine the precise amount of water to be applied. So this adoption, mostly in Africa, is influenced by climatic conditions, water availability, and policy framework and technological infrastructure. The next one, please. Now, these are the core technologies in smart irrigation. The first one, that you need the IoT, Internet of Things sensors. This one measures the soil moisture, humidity, temperature, and water levels. Now, when this is gotten, you can actually optimize the irrigation. That's applying what you need to apply. Then you have the AI and machine learning. This one predicts optimal watering schedule based on historical and real-time data. So it adjusts the schedule dynamically. That is, if there's any change, it does it immediately so that we start, because every drop counts. Then you have drones now. It provides area imaging to detect crop water stress and irrigation efficiency. Now, when you use drones to check, to provide area images, you can actually tell areas where it's over-irrigated or under-irrigated. Then you have cloud computing and mobile apps. This one allows farmers to monitor and control irrigation remotely. They must not be in the farm physically. Then you have the smart drip and sprinkler system. This one ensures precise water delivery to the plant roots. The next slide, please. Now, this is how it works. The first one, there is data collection. Now, the sensor track the moisture, that is, then weather condition and crop hydration levels. That's what is the amount of water that the crop needs? What is the growth stage? Now, what is the weather condition? That is collected. Then the next thing is analysis. The AI, 2 minutes? Wow. Then you have automated watering system. This is the circle, how it works. The next slide, please. Then the benefit of this, you have water conservation, there's increase in crop yields. The next slide, please. There's cost reduction, climate resilience, and sustainable farming. The next slide, please. Now, barriers to smart irrigation. Why is it difficult for mostly our clients here to adopt this method? First one is high initial cost. The sensors, the AI controllers, automation equipment are expensive for smallholder farmers. Then you have limited digital structure. We have weak internet connectivity and poor power supply, mostly in the rural areas. This one will hinder adoption. Then farmer awareness and training. A lot of farmers, some of them are illiterate, some of them just use past experience to irrigate their farm and all of that. So it will be very difficult for them to adopt the system. Then we have cyber security risks. Next slide, please. Then you see some global trends in smart irrigation. You see it's being practiced in US, it's practiced in China. Next slide, please. In Israel and California, they're already up there practicing this, like major company that deals with drip production and distribution. They said that when smart irrigation is being practiced, the crop yields extends by 50% while using 30% less water. The next slide, please. Now in Egypt, look at what is happening. They are already adopting it. Then Morocco, though they have critical condition why they need not go into this, but you see that they are already advanced in the use of this method, and it has improved water efficiency by 30% while increasing citrus crop yield by 20% of its arable land that is irrigated. The next slide, please. In Ghana, it's already been practiced. Then also in Kenya, time has failed me. The next slide, please. Then, but for Nigeria has been exploring sensor-based drip irrigation to improve water efficiency. Like in BUK, we have that they use a tensiometer to do that. and it gave them 5% less water saving and 6% increase in water productivity. While in Jos here we have, Jos where I stay, we have the Green Eden Farms. They have developed AI-powered soil sensors that provide real-time irrigation recommendations via mobile apps. Okay. Strategies to increase adoption, government support and subsidies, public-private partnership, affordable and scalable solutions. Information for precision water management. So we've discussed about the key challenges. So with strategic investment and innovation, smart irrigation can drive sustainable agricultural transformation.
Thank you very much. Now, the next person is Prof.
Thank you very much. Well, that is my name. I'm the National President, National Association of Yam Farmers, Processors, and Marketers. The purpose of this paper is to say, let us put more crops under irrigation. And one of the crops that I am advocating that we put under irrigation is yam. Yam, you know the importance of yam. We are number one globally. We all know that. We also know that in certain cultures in Nigeria, when you see the sign food is ready, you know what that means. Food is ready means pounded yam. We also have about 18 different yam products for promotion, including yam bread and yam fries. You've eaten yam bread before? Very sweet. Despite the importance of yam production in Nigeria, importance of yam production in Nigeria remains reliant on traditional rain-fed farming systems. For those of you who care to know, if you are a man and you need staying power in the other room, yam is what you need. Not all those drugs that people take and have high blood pressure. If you're a woman and you want multiple births, yam is what you need. Next slide. There are limitations associated with rain-fed agriculture, which we all know. There are low input practices, limited access to modern agri-technologies. Yam, it's a high water requirement crop and is very sensitive to water stress. And as a result of issues of climate change, if we do not irrigate, we may have a challenge in the future where we have total crop failure. The next slide. It all talks about limitations and risks that are associated with rain-fed agriculture, for which yam has been under for decades. Since you knew yam, it has been under rain-fed agriculture. So there's a new innovation that speaks to the issue of irrigated urban yam farming in sacks and bags. Many of you may have seen a lot of this online. You have your cement bags, and this is me in here in my own compound, and that is the yam I grew in my own compound. You can see in the last picture the wall there, and it was by irrigation, just applying water within the compound. The next one. This is the kind of harvest you have from sacks and bags yam farming within the urban area under irrigation. Just apply water and then you have a harvest like this. You could see the yam planted against the wall. The next one. So that is the process. You have the sack, soil preparation, seed planting all the way to your harvest. It is in the middle of the table. You have the prospects of having yam in sacks and bags, and then there are challenges. Next slide. It eliminates completely hazardous pesticides. I belong to an NGO. We are campaigning against use of HHPs in agriculture because of the residue that we have. And so all these highly hazardous pesticides, when you do your yam farming in sack and bags in your house, you don't apply them. So you have something that is close to organic. Yes, next one. Okay, so we have tried to see whether we can move the irrigation in the urban areas under bags and sacks farming to the field. So we tried to find out from 2015 to 2024. We looked at systematic literature review and meta-analysis. If you look at the real paper, there are about a table there with about 60 entries. But we were able to get 37 publications that speak to irrigation, yam irrigation in the different geopolitical zones in Nigeria, the 6 geopolitical zones. Unfortunately, in northwest and northeast, we don't have data. But in the other geopolitical zones, we have literature showing that some form of yam irrigation is taking place. Basically, surface irrigation methods, the flood and the furrow, and then what we call aeroponics. Next slide. So, surface irrigation, a lot of people have spoken to the aspects of surface irrigation. The next one. This is aeroponics, the seed yam system under aeroponics, and the process is as interesting as you have it there, from the temporary immersion bioreactor to the acclimatization and the aeroponic system. You go into the nursery. One good thing now is that with one node, you can grow your yam. You know, before it was very, very difficult. There was no seed system for yam. But now there is a seed system for yam, and you can grow your yams from just one node vine, and that is what you find here. Yes, the next slide. Okay, so the yam irrigation that were found in literature being adopted, there are a lot of issues, technical, economic, and social barriers, issues of water scarcity, inefficient use that other presenters have spoken to, poor water management, and also constraints, the lack of government support, inadequate extension services, and the weak institutional framework. The next one. There are opportunities for improvement, though. We think that there are a lot of many more things we can do apart from putting yam under irrigation. We can promote yam irrigation in Nigeria. Next one. We all know that yam is both a food security crop and export promotion crop. And I keep telling people that nobody is hungry and is looking for hibiscus or is looking for beniseed. And if we want to solve food security problem in this country, we must look at this crop. And we must see how we can grow it at least 2 times every year. There are opportunities for, we are still on that slide, for transformation of farming systems. Right now, we plant yams on mounds, but we are thinking that we should change the farming systems to ridges. In ridges, we can go from about 4,000 plants per hectare that we have right now to 10,000 plants per hectare. It allows for mechanization. You see why yam is not being promoted in Nigeria is because everything about yam is manual. And you can never see any government buying hoes and giving to farmers, yam farmers. I mean, government can never budget hoes, but the hoe has remained the primary tool for cultivation of any tuber of yam that you see. The next one is that there are opportunities for mechanization, ridging, planting, and harvesting. If we change the farming systems from mounds to ridges, so we can design yam planters, we can also design, we need ridgers, ridgers that have very high clearance, so that the ridges for yam, they are not like if you are planting rice. So very high clearance ridgers, so we can do our ridging, we can do our planting, and even harvesting can be done. And with this is the rooted one-node vine. With this, agricultural engineers can be able to give us machines that will be able to do the planting. The next one, we have issues of adoption of good agricultural practices because irrigation is a factor. The next one, opportunities for adoption of sprinkler irrigation. This is yam under irrigation in Ghana. I was in Ghana on sabbatical leave, the University of Ghana, and on the university campus, these Israeli guys were planting yam under irrigation, sprinkler irrigation. And if it can be done, this was the harvest. Okay. If it can be done in Ghana, we can also put yam under sprinkler irrigation in Nigeria. Next one, mitigating effects of climate change through irrigation. Next. Conclusion is that let us put yam under irrigation. I think it's about time we bring more commodities under irrigation and also include us in your dry season farming for yam. And as an association, we want to promise you that we are ready, good to go. Thank you.
Thank you, thank you, thank you. Okay, the next speaker, Mrs. Okay, let's have questions, please, quickly. Question to the first speaker, smart irrigation technologies. Any question? Yes, please. Any other person? Okay. Okay. Where is it? Thank you.
Good afternoon. All protocol duly observed. My question is based on smart irrigation. For we in Federal Ministry of Water Resources through the Department of Irrigation and Drainage, we are trying to promote smart irrigation. But we've been faced with a series of challenges. One, we are faced with vandalization because we are trying to use the underground water. When we dig borehole, our submerged pumps will be stolen. The pipes will be, in fact, the one we just concluded in Oyo State, when we went to commission it, we found that the farmer set fire inside the farm and the whole drip lines were melted away. So we don't know what to do because we are still on a trial stage now. And we want a situation where we'll get it right and roll it out. Currently, we are doing 5 hectares. This year, we are trying to roll it down to 10 hectares, but we are still facing challenges. So I don't know, because I think what we are now thinking is this: okay, what will we do? Whether to bring all our farmers together and train them on the maintenance, how to take care of them, even if they have to remove it during the rainy season, how to quietly. So we are now adding more facilities into our drip irrigation farm. Like now we are doing a farm shed, but still we are still facing challenges. So I want you to please educate us a little bit on how to overcome some of these challenges. Thank you.
No, mine is related to what she said. I wanted to contribute in that area. That doctor, you gave us smart technologies, beautiful ones that are used in other climes, and then and after all those technologies that you reviewed, you now came up with challenges, limitations, and you said these limitations make it difficult for our farmers to implement. This limitation, I mentioned a lot of limitations that made it, is making it impossible. If I use the word difficult for our farmers. So when we do research, if you do research, we have limitations, but you don't just don't stop at narrating the limitation. You have to provide how you overcame it. So when you say, if they are doing this in other climes, and I think the purpose of this conference and why we are here is for our farmers to adopt it. So if there are difficulties, try to do further research, and I think that is the area she's also asking, to provide the solution. Because when you ended up saying, this make it difficult for our farmers to adopt, so it means you have not passed the right info. So find out how to overcome the limitation. That's what we do in research. You have limitation, but you must show how you overcame that limitation.
Thank you. Any other question? Okay, let me put him here.
Yes, it's for the second presenter. Okay. I understand that before yam can sprout, there has to be some temperature rise or something. And so if that is true, the possibility of using irrigation for yam, I don't know how very workable that is, particularly because we understand that yam grows, with some certain climatic condition. And so when maybe in the dry season or in Harmattan now, and you are planting yam and you are irrigating, I'm not sure how it can work.
Thank you. My question also, the yam under irrigation. My question is, how many months the cropping cycle? Because this is very important, because if we are going to do it maybe at commercial level, this factor is going to be very important. It's because of the profitability issue. If, for example, yam will take like 6 or 8 months, the growing cycle, then the question of using irrigation is probably going to be not profitable. Cost effectiveness will not be there, and everybody, if it is commercial, everybody is looking for profit. So the profit may not likely be an issue. Yeah, so it's going to be an issue. So this is a question, because if yam has a longer gestation period, then it's an issue. Yeah. And then my second comment is on the, Madam, you talk about the Federal Ministry of Water Resources working with farmers in Ibadan or somewhere in Oyo State. Because I wonder, because okay, Sokoto, okay. So my question, are you working directly with the farmers or through the river bathing? Okay, through the river bathing. And in my opinion, even if you are working through the river bathing, maybe the approach is slightly wrong. Because the Federal Ministry of Water Resources is supposed to provide the infrastructure, probably the policy as far as water utilization is concerned, water management and so on. But working with farmers is the primary responsibility of the Federal Ministry of Agriculture. So my advice is collaborate with the Ministry of Agriculture, because this is one of the issues we are facing in Nigeria, the fragmented coordination. The Ministry of Agriculture, the ADPs at the state level, the Ministry of Water Resources at the federal level, they are not working together. And this is always an issue. So why don't you work with if you are already working with the river bathing, good. Then work with the ADPs, for example, at the state level. Work with the Federal Ministry of Agriculture at the federal level, so that you have a coordinated approach. Otherwise, you are going to continue to have a problem, because your mandate is not working with the farmers. Your mandate is to provide the infrastructure, the enable environment for the use of the infrastructure. But actually, the Federal Ministry of Agriculture, the ADPs at the state level are responsible for dealing directly with the farmers. So my advice is probably adjust your approach if possible. Thank you.
After providing the infrastructure, definitely farmer is going to be involved, the user, which is community, because we are targeting women and youth. Our micro irrigation is targeting women and youth, so that there will not be overflooding of youth from the rural to the urban. So what we are trying to achieve through the river basin is, when we provide infrastructure, we hand it over to the river basin. The river basin will now work with the community to ensure that. But you find out that even before, immediately before you even finish, whatever infrastructure you put is taken away. And I don't think federal government will continue to do that. We are trying to like even also, especially in the West, getting land, getting the community buy-in is a problem. For instance, we went to Ondo State. After they accepted of giving us a land, we dialogue with them with the river basin. By the time we got back to Abuja to come and strategize, they called us that land, they are not ready to release it. We want to come and use that to take the land away from them. So I now asked them, can federal government come and pick land and take to Abuja? It's for your own benefit. So that awareness, now we are trying to do some what we call sensitization. We go around sensitize them. That's the phase we want to do now. Before we even say, okay, we are giving any community, we want to sensitize you, tell you what it entails. If you are interested, fine.
Thank you very much. Mine is to the young farmer or young irrigator. Prof, thank you for that presentation. In fact, it's exciting for some of us who are in the academic environment. We would want to try some of these techniques to see that whether irrigating yam is feasible. I'm interested in some of the results you showed about the presence of irrigation in the 4 regions in the country and the absence of it in the other 2 regions, that is northeast and northwest. I don't know, what type of irrigation were you able to identify in those other regions that are not present in the northwest and northeast? Thank you.
Please, I have one question to the smart irrigation. You show us a clay pot. Is there any way can we make that one smart? I think that is a local technology. Can we make that one smart so that, because I've heard about it before and it's very, very effective. Is there any way we can make that one smart so that it will affect all the crops? It can be used for all the crops. Please, that's the last question. And then give him the
Yes. I want to congratulate the presenters for their innovative issues that they have presented related to water resource management and crop production and what have you. I'm particularly impressed by the presentation from the Makodi man on irrigation of yam. But before let me say I was really impressed because it reminded me of a question my former vice chancellor asked us. Do you really do research in agriculture? Because he's a biochemist by professional calling. So he was thinking we don't do any research in agriculture. And I asked him a question. If you want to buy mango, which one do you prefer? Is it the exotic mango or the local one that sticks to your teeth after eating? So he prefers the new variety. I said, how did you come about the new variety that you prefer? Then he was amazed. I said, it's through research. It's the same variety that through breeding was converted into this. So you see, these are issues that we need to be addressing so that the ignorant will know we're addressing the food challenges in agriculture through the research we are doing. I'm also impressed by because somebody was saying that Africa must find African solutions for its own problem. And these approaches are really practices that farmers are doing and they can adopt with low cost, like changing from mount to ridges. It even, reduces the, yes. So, but I also want to pass an advice regarding the issue of security, the vandalization, what have you. You see, if you go to the north now, they grow onions, they grow potatoes, and these are crops that if you don't take care, people will just harvest them overnight when they are due for harvesting. Vandals would take. So what they do is they organize themselves into a, what do you call it, vigilante group or groups. And they also dry their paper and what have you on the farm, on the fields, so that when they get dried, they take them home or to the market. So what they do is they organize themselves into security outfits, and then they maintain those things so that they don't get stolen. Sorry. So you can maybe understudy what our farmers are doing there, and then try to borrow and then implement to address this vandalization using local participation. Thank you.
I just want to say one thing. You see, there is so much distrust by the farmers whenever they hear a government agency is coming. I'm sure that is what is happening in Oyo State. Farmers don't trust us. Neither the local government, the federal government, they don't trust us because we have not impressed them. I'm sure that is a problem you are having in Oyo State. If the farmers own the project, I'm sure they will not destroy it. Please, the next speaker, we finished. Okay, you have not responded, sorry.
Okay, I'll just quickly respond. The first one, you're talking about this picture, using the use of clay pot. If you can make it smart. To me, it's already smart because it's the roots of the plant is through suction. It pulls water from the clay. So if it has gotten its crop water requirement, suction becomes zero. Okay? Prof was talking about, I was talking about the limitations. The truth is the limitations abound. We are in the Federal Capital Territory now. You know that at times you want to even make call. Network will be suspended for some time. Then talk more of those who are in the rural setting. Like even some of the meteorological stations, we don't even have access to data. We don't even have access to information. So some of all these things, the enabling environment is not there for the farmers to apply some of all this stuff. Madam, you're talking about adopting smart irrigation in that farm, that specific location. I don't know how smart is the farm. Because like example, when I was coming to Abuja, I sat with a lady, she runs a restaurant in Jos. She was through her phone monitoring all the workers. So if you say you want to go smart, that means you go smart completely. If somebody comes near the boundary, it will pass a signal to you. You can easily tell that somebody is around. Because as it is now in Nigeria, the farmer is not even safe. Talk more of the farm. You understand? So for me, if you want to go smart, you go smart completely. You can actually monitor all those things. Whatever is happening in your farm, it can be monitored remotely from wherever the farmer is. So thank you.
Yeah, I think what we have found now is that we can plant yam any time of the year. Once you have seed yam that has broken its dormancy, and these seed yams are available from the seed companies that we now have in Nigeria. Dao Green is in Kaduna, Strategic Seeds in Ebonyi State, IITA Go Seed. There are a lot of these seed companies now that can give you seed yam, and you can plant anytime. Now that we know with irrigation, you can do your planting. Right now, under the rain-fed agriculture, we are yet to plant. Even as national president, I'm yet to plant my yam. Okay? It is this April now that we will likely, if the rain stabilize, because there's danger of planting if the rain does not stabilize. You go into a drought and there's no rainfall, the seed yams get rotten, get cooked inside the soil. So we need to be sure NIMET can assure us that we can now plant, so we can go ahead. Now, if we plant in April, because it is rain-fed, we wait until the foliage is dry in December before we do our harvest. Yam must not wait until the foliage is dry. You go to IITA, they harvest when it is still green. So if you can do your harvest in 6 months, you can harvest and do another planting, you know. And I think okay, the last question Prof asked about the irrigation methods. You know, we have yam endemic states in Nigeria. Apart from Taraba in the northeast and northwest sector, there is no other state that is into yam production, as it were. They are into marketing, yes. We carry yams from the north central states, and then we take over to the north. But they are not into production. And I think maybe that is why the two irrigation systems, methods we have, are basically in the other 6 geopolitical zones, in aeroponics and then surface irrigation. But we are now thinking that why not? Why can't we farm yam in Bauchi State, in Borno State, under irrigation? Why can't we just try it? I think this is the whole essence of this paper.
Okay, good evening, everyone. My name is Gladys Igomu. I'm the founder of Etema Farms and Agro Consultancy Limited. Please, the next slide. Africa is the fastest urbanizing continent in the world. Its population is projected to reach 1.3 billion by 2050. This rapid increase will inevitably place immense strain on urban food system. Compounding this challenge is climate change and the recent insecurities faced by farmers in rural areas. To curb these challenges, urban agriculture or urban farming has emerged as a vital strategy for promoting food security, livelihood, conserving water, and fostering sustainable urban development. Urban agriculture is the conversion of any available urban space to be used in the production of food crops, or raising animals, the case may be. So urban agriculture might either be for growing crops or raising animal, whatever you choose, but in the urban area. There are different types of urban farming. Examples include rooftop, where people are growing food on the roof of their houses, maybe on their balcony, just any space at all in case you don't have access to maybe the ground. There's sack or container farming. I was so impressed when Prof was talking about sack farming. And just to digress a little, I actually did sack farming, yam sack farming last year. We harvested in October and we planted another one in February. So we did about 200 bags in the farm. But unfortunately, so far the number that have germinated is around 30 because the others cooked. The mistakes we made was after planting in the sack, and it's Gwagwalada, by the way, very hot, we didn't mulch it. So, and we're giving water, we're irrigating by hand, we're using water hose to irrigate. So, but the temperature rose at some point, and when we were digging it, everything was cooked and rotten, by the way, but at least we got like 20. So when we are going to do the next one, we'll know how to mulch it and take better care of it. So, okay, so please can we just go back? So other urban farming could include rooftop, the sack or container farming. We have vertical farms, there's hydroponics, there's aeroponics. But for this particular part, we're focusing on vertical farms, hydroponics, and aeroponics. So from the table there, we can see the 3 urban farming system and then the water usage. You see vertical farms, they use 70% water less compared to conventional farming. Hydroponics 90, and it gets even interesting as we go to aeroponics. as we now, as you keep going, advancing in the urban farming system, you use less water. So if water, as we are suffering from climate change challenges and other things, if you are adopting this urban agriculture, you use less water and you are able to manage the remaining water for other things. So vertical farming is a type of farming that is done vertically. Simple. So most of our farming, the conventional way is to grow crops in a horizontal manner. So if you are living in urban area, if there was one thing that COVID taught us is that food is very important. By the time when it was COVID, you could have the information that there is food maybe in the next community, but you didn't have access to it. You couldn't go, even vegetables or whatsoever kind of food. But if you have urban farming or vertical farming, this is an advanced stage of urban farming or vertical farming. You can use even PVC pipes in your house to raise your own urban farming. If you want to go soilless, you can also use maybe coconut fiber, sawdust, rice husk to do it, provided it's just going vertically. So do not be like, oh, this is so advanced, I can't do it. Yeah, if you want to go commercial, or if you have the funds, you can go advanced, but whatever farming you are doing that is going vertically, you're already practicing a vertical farm and urban farming. And this is what you can do in your house, at your balcony, no matter the little space you have. So what are the benefits? We already saw the water, increase crop yield per square meter, because let's say per square meter, if you are growing vertically, you grow about maybe like just 4 to 5 stands of tomato plants. But if you are going vertical, you can go up to like 30, because you are minimizing space. As you are stacking them higher, the more space or more crops you can grow. The challenge is, of course, the initial high setup costs, the technical expertise, and high energy consumption. If you are using the automated system, you are going to have to plug it to energy to power it. So there are different types of hydroponics, depending on what you want to grow and depending on the one that is available to you. So we have all these types of hydroponic systems. Please, next slide. Aeroponics. Aeroponics is a system of urban farming where plant roots are suspended in the air and nutrient-rich water is delivered to its root. As we can see, this aeroponic system, the roots are exposed while nutrient is misted to the root. So instead of it being in the soil, like we know, what really makes a plant to grow is not just the soil, but what is in the soil. So if you are able to take what is in the soil and put it maybe in water, as in form of hydroponics, or in mist form, as in form of aeroponics, your plants will be able to grow. So we know we need nutrients, we need water, we need support, anchor, we need light. So when all these things are gathered, you'll be able to produce food. From the picture of the aeroponics there, you see that there is an anchor holding the stem of this plant, and then the root is open and dangling, and then the pump from down, you can see, is bringing out water that is rich in nutrient. So as it's supplying the roots, the plant is able to grow and yield fruit. So the benefits, as we also saw, it uses less water, you have year-round production, because you have access to water and nutrient. You can grow as much as you want. If you are doing leafy greens that grow within 3 weeks to about 1 month, that means you can go about 12 cycles in a year, instead of waiting for rainy season or rain-fed one. So the challenges are still similar. So what are the economic and environmental impacts? You can see creates job, reduce food import dependency. We grow tomatoes like beef tomatoes, like cherry tomatoes. Before, you import all those things to Nigeria, but now it's being grown in Nigeria, so you do not need to import them. Lower carbon footprint. So instead of growing in far areas and then transporting and bringing to the urban area, people in the urban area can easily grow now. You might be growing and then your your neighbor or the people living in your estate to just come and buy from you. So they are getting it fresh and getting it faster. So the social benefits as well, increased nutrition security, because the problem we are also having in Nigeria is not just food security, but most of the food we are eating is void of nutrient. Wow. So if you are growing around, you are going to have more. So what's the conclusion? Advances in urban farming, particularly vertical farms, hydroponics, and aeroponics, offer significant potentials for addressing the challenges of urban food insecurity, climate change, and sustainable development in Africa. These innovative methods can increase crop yields, improve water efficiency, and enhance food security while promoting sustainable urban development. Next, please. Okay. Oh.
Very good timing. Thank you very much. The last speaker, Dr. John. So after that, two questions for each presenters. First two for the first presenter, and next two for the next. Thank you. You're welcome.
All protocol duly observed. My presentation is on a meta review on the use of artificial intelligence in irrigation practices in Nigeria by Engineer Dr. John Audu from Joyce Taka University, Makurdi, former University of Agriculture, Makurdi. Now, these are the old methods of irrigation practice. It shows the inefficiency why artificial intelligence must come into irrigation. Traditionally, using traditional method, it leads to significant losses of water. It hinders water efficiency, inadequate infrastructure. It also, because of climate change, increase in rainfall causes some inefficiency. Limited awareness also happen in irrigation. These are all old traditional methods that irrigation is taking place before AI. Now, since we know that these are the problem and we have identified that it is important to bring in AI, we are challenging the traditional method using AI. Now, the roles of AI in irrigation are using AI algorithm to predict some irrigation outcomes that can be used for informed decisions making in irrigation activity. We have IoT-based smart irrigation systems. We have remote sensing technology, and so on and so forth. All these technologies being put into irrigation improve water efficiency and enhance productivity. Go ahead. Now, why is the rationale for doing a meta review on irrigation? There are research gaps that have been found in this old system of using irrigation. There are limited specific studies in regions. We don't know which regions uses what irrigation as that applies AI in each of these in Nigeria, because the study is specifically in irrigation. We lack empirical data and challenges in adopting AI, and policy of institutional gap, meaning there is no gap between the institution and the farmers. Their researchers don't get to them. All these are gaps noted. Now, when we do meta-analysis for this, there are good to have accessibility, applicability, evaluation effectiveness, and we're going to identify trend. So, one of the rationale is that there is need for AI-driven irrigation solutions. Now we have to look at existing research on AI in agriculture. We have to know that first. Then we make a comprehensive analysis of AI in Nigeria, and we identify gaps, looking at the region, lack of empirical data, challenges in adaptation, policies, which I have mentioned before. All these are part of meta. Go ahead. Now, there are research questions that helps us to know whether we have the review has already we have achieved the aims of the review. Research question number one in this meta review is to say what are the existing applications of AI in irrigation practice in Nigeria? 2, how has AI improved water management in crop productivity in Nigeria? 3, what are the major challenges that hinders the adoption of AI? And 4, research question 4 is the policy and technology intervention that can enhance AI. Now, the objectives of this meta review is to examine current application of AI in education in Nigeria, to assess the impact of AI in water management and crop productivity, and to identify challenges and future research. Go ahead. Now, methodology, the framework for the meta. 1, we have to identify the studies, screen them, evaluate them, analyze them, and synthesize them. Look at the other systematic way we used to. We start identifying relevant studies. We use Prisma, which is a guideline for systematic review. Then we come down to databases. Bases we use were Google Scholar, IEA Explorer, Scopus, Web of Science, and Agricultural Research Base. Go ahead. Go. Now, these are keywords used for the research. In the meta result, artificial intelligence, irrigation, these are things you put on database to get where we are. Then we have Boolean operations that also go through R or this in order to get these things. And then this filter, frameworks, that is time frame. What time, which year are we talking about? All these are part of the review. Now, we go to the selecting criteria. What was included and what was not included in these meta reviews? Now, application of irrigation. In any study that has application of irrigation is included. If it is relevant to Nigeria, it's included. If that study has empirical and case studies, it's included. If that study is peer-reviewed, it's included. What was not excluded? General application that talks about everything outside irrigation was not included. Options-based articles and non-AI studies and so on. Now, let me, because of first, categories. Go back small, please. The categories that was used for the meta-analysis were type of technology, irrigation parameters, monitors, impact water management, impacts on crop yield, challenges in identification, policies, and insurance. Go. Now, this is the study. As we go down, if you can see, we start from 215. 215, north central, north east, northwest, north south. Then we go through and make studies, take studies that are having data on them, year by year. Go, keep going. Keep going year by year from 215 to 224 for each region, geopolitical regions where the studies take place. Go. Now, stop. We have done that to 224. Now, looking at answering the research question number 1 first, which AI application are most in that AI has been applied to most? We find out that surface irrigation from all were the most irrigation practice that AI has been applied to, followed by sprinkler and tricklet. And the most underrated ones are the subsurface irrigation. Go. Then, looking at the states and the regions where this AI has been applied to, so far from the papers we have looked at, we find out that most of them, you see, these are only few states. Some other states do not have this thing, but they are associated because the study was done sometimes between regions, not just one state. Go. Now, impact on AI on irrigation efficiencies, which was on the table there. We find out that North Central seems to be the highest because in using AI, their studies has given more irrigation efficiency, followed by Northeast, and then South-South, and then Southwest. Then we have South-South and Northwest. Though they have got some study that have gone there, but they are not as the others. Please go. Now, crop yield by geopolitical zone is not much based on the study. Most of them, the study we had, there are little gaps, but they are still not, though we can't say it's significant yet until we do an ANOVA test. But at least by looking at the graphical representation, there are some increments and there are some reduction. We see that North Central has high yield in their crop yield when using AI to predict the outcomes. Now we see the lowest there is Northwest. Northwest has, because most of the Northwest datas, Southwest, most of the Southwest datas are mostly on automated irrigation. And they applied it for very little crops. And so the yield they use for the experimental studies are smaller compared to North Central, which most of them are surface irrigation, and they are predicting irrigation parameters. Let's go, let's go. Now, challenges and barriers from all the studies that have been taken. High cost of setup seems to be most of the highest challenges in the irrigation application of AI in irrigation, because most of them, they spend a lot of time to get data, and also, yeah. Now, limitation of funding for data collection follows next, and then technical is okay. Now, future prospect and recommendation. One of the things for recommending from the study, all the study particularly insisted that government and private partnership should gear adopting AI, followed by just only government intervention. Go. Now, in conclusion, the whole study, when looking at it, has improved. It has shown that AI has improved irrigation efficiency, has increased crop yield. Now, when you come down, now AI has transitioned to advanced system. There are barriers. If barriers are there are technical challenges. But if there are no barriers, we need supportive policies, which brings down us to either private or public research and development support, and then the future, and then we look at the lower, what is there, the lower part of this thing. Thank you.
Thank you very much. Please, two questions to Ms. Gladys. Number one. Number one, number two, number three. I give, that's all. Two questions to Dr. John Audu. Two questions. Okay, I will give the last person, and then we have 4 questions. Thank you. Start with the lady down
there. Good evening, everyone. My question goes like this. I need a clear explanation on aeroponics. Yes. Is it grow on hair, or where did they place the roots? I'm confused.
Good evening, everyone. My name is Kasim Abdullahi Baba from National Water Resources Institute, Kaduna. I have actually had 1 or 2 discussions with the presenter. Actually, it is glaring that the hydroponics system is capital intensive, but basically it's the nutrients. The nutrient is expensive, and we've devised means of cutting costs. I've worked using rabbit urine as organic fertilizer, because the rabbit urine contains sufficient amount of nitrogen, phosphorus, and potassium. These are the basic ingredients that the plant needs. I actually harvested the rabbit urine and then use it to grow lettuce in hydroponic system, and the cost was cut at 50%, which she can also try it in that perspective as well.
Good evening. My question is a question on board, like an observations. Urban farming is very, very important, and the potential for it to progress in a country like Nigeria. But in your own presentations, you fail to showcase what are the yields, expected yields, so that it will now boost the interest of the farmers, and what are the cost implications, so that farmers will be so watchful on comparing the cost of producing whichever crop using either the hydroponic and the aeroponics, so that in your presentations you need to showcase all these things, so listeners will look at in terms of yield and in terms of cost effectiveness. How do I now base my own choice in order to progress? That's my question.
My question has to do with the policy gaps, especially with respect to some states where they feel that we need to beautify our urban areas. So they tend to come up with policies that discourages urban farming. What is your own opinion on this. What have you found as challenges with our governments? They feel that farming must only happen in the bush. It should not happen in the town because it tends to deface the environment. And number two is we have a whole department of soil science in our universities. Now you are talking about hydroponics, aeroponics, vertical farming. So I can grow my crops in air. That's what you are saying. Do I need the soil? Do you think that our soil science departments will have to look inwards and maybe bring in some aspects of air science, so that it's not only soil science, because now you can grow without their soil. So what policy, what do you suggest? I'm a director of academic planning in my university, and I'll need advice.
Okay, thank you. Aeroponics. So it can hang in the air. Basically, you are just, as we have mouth, we animals or human beings, we use our mouth to eat. So for plants, root is part of where their mouth is to. That's where they feed from. So what makes a plant to grow, outside the fact that, of course, they still take photosynthesis through their leaves and all that, the root is one of the main parts where they get nutrients. So when you give water and nutrient through the root, it makes it grow. So either you are hanging it, or is in the soil, or is in a container, provided the root is getting nutrient and water and everything it needs, is going to grow. You understand? So there are some hydroponic systems that the plants are actually hanged up like this, and you are seeing the roots dangling. Then there is a mist of nutrients to the root. There are some other hydroponic systems that it might be in a covered place, but the nutrient is still misted to the root, even if you are not seeing it. It could be in PVC pipes, it could be in other containers. So that's what is really about. So for urban farming in urban areas, there is a place I went to. I was invited to one garden in Gwarimpa. It's a new area, they are developing it. So in that estate, they actually set a space out for their garden. They have horses there, they have pigs, they have other animals, and then they were proposing a site for greenhouse, so that everybody living in that estate will have a place where they will go and buy their vegetables. In fact, I was discussing with somebody the other day, we're like, every community in urban areas should at least have a garden. Maybe like a greenhouse or a hydroponic system where, God forbid, if we're on lockdown, at least that place can supply food. And if children are on break, like they are now, they can just go there and work, volunteer to work, gain knowledge, and, stretch out. Even as adults living in that environment, weekdays or anytime you have chance, you can just go there and volunteer to work 30 minutes, 1 hour. You expose yourself to nature, you learn new things, and you come back happy. So I personally think, if it's even possible, the government should make a law that in every estate or every community there should be a small place where there is an urban farm or where there is a garden, so that everybody in that area can participate from getting things from there. Maybe the people living in that area can pay less. Then finally, sir, regarding the urban agriculture taking the place of the conventional farming, I don't think it will ever happen, because you see from the introduction and from all the papers presented earlier that Africa is urbanizing at a very fast rate. So a lot of people are moving to the urban area, and we are multiplying in number. Like because of maybe better healthcare or development, population is becoming more. So we feel that as an urban farmer, I feel that the conventional farmers alone will not be able to handle the food security or insecurity problems of Nigeria. So it's good for we in the urban areas to join hands so that we all meet halfway, and then there'll be food in enough for everyone to eat. Thank you.
There are some crops, they need soil. Thank you very much. Please, I want to use this opportunity to challenge my young rapporteur. You have learned now, very cheap you can start farming. Start yam farming in Sak. Please, you have 2 people you can consult here. Get their contact. Please do that. Thank you very much. We are done for today. They have been hurrying me to close. Thank you for everything. So we see tomorrow. Thank you very much.